Okay, welcome back. We'll be discussing Chapter 4. In Chapter 4, we'll talk about control structures, especially the first type of control structures called selection. We have been talking about control structure if, for example, if and else for the second project and third project. So we are very familiar with these control structures we have been using for the last couple of chapters. So we'll actually go through this chapter much quicker because we have some understanding of how to use these control structures. In this chapter, there are three control structures discussed: if else, and switch in case. So I'm going to go through these terms much quicker. So let's actually talk about, so this chapter will talk about how to use the selection such as if and else, examine the int and boolean data types and logical expressions, some of the logical operators. If you remember, we talked about relational operators. There are 6 relational operators such as equal, not equal, less than, greater, less than equal, and greater than equal. Those are the relational operators. There are 3 logical operators as well, which is not, and or. Not, and or. And this is what they look like. So this is your not operator, your and operator, and your or operator. So this is not, and or. So these are the 3 operators. These are called logical operators. So we'll be using these 3 operators in this chapter as well. So we'll talk about how to apply these operators for a string data type. And at the end of the chapter, we'll talk about switch in case. All right, so this chapter talks about a computer can proceed in sequence by using some kind of branching or selectivity, by repetition, which is the following chapter. We can repeat things in a loop, or by calling a function, another chapter after that one. So the 2 most common control structures, Chapter 4 talks about selection, Chapter 5 talks about repetition. So these are the heart of the programming because these control structures allow us to check conditions or repeat things. So in this chapter, we'll be talking about selection. So I'm going to skip that part here. So when you are checking these control structures, you will evaluate to either true value or false value, true or false. So there are only 2 logical results. Either you get a true if the condition is checked, or you get a false. That's what this slide number 7 is showing you. For example, 8 is greater than 3. Either you get true or false. These are the relational operators we discussed in the past. And, equal, not equal, less than equal, greater equal. These are the 6 of these relational operators in Chapter 4. Right, let's move on. And then it shows you various examples. For example, 8 is less than 15. That's true. 5.9 is less than 7.5. That's also true. So you evaluate the values either to true or false. Same thing for characters. When you're checking, uppercase R is greater than uppercase T. What do you think? Is 4 less than 6? Yes. What about this one? Uppercase R is greater than uppercase T. So that might be false here because if you look at the ASCII value, the ASCII chart, you can Google on it. You can type ASCII and you can find the chart. Each character on your keyboard has a value assigned to it. For example, your uppercase A has a value of 65. Lowercase a on your keyboard has a value of 97 assigned to it. So each character on your keyboard, including a space bar, number 0, escape key, all these characters have an ASCII values assigned to them. So here is just basically comparing different types of characters and values. And we are very familiar how the if control structure works. This is a one-way selection, which means it doesn't have any other branching out to anything else. Let's continue to move forward. And this is a two-way selection. So you have if the first condition is true, the first statement will be executed. If the first condition is not true, the else part will be executed. That's what this slide is showing you. Okay? And then we have three logical operators, not, and or. No space between or and and operators. So ampersand sign and ampersand sign, no space. This is a pipe symbol. You can find where your enter key is, right above the enter key. The not operator reverses your condition. So if your expression is true, by applying the not operator, it will become false and vice versa. Okay? So not operator is also useful sometimes just to negate certain things in order to process the data. So this one here, on slide number 20, it is your truth table for AND. For AND truth table, if the first expression is true, the second expression is true, then your overall result will be true. If the first is true, the second is false, the result will be false. If the first is false, the second one is true, the result will be false. If the first is false and the second is false, the result will be false. So in case of AND, it's very picky about it. In case of AND, all the conditions must be true in order to get the result as true as well. In case of OR, it's much more flexible. In case of OR, if the first is true, second is true, the result is true. The first is true, second is false, result is still true. If the first is false, second is true, the result is true. The only time the OR condition doesn't work, if the first condition is false, second is false, the result will be false as well. So you want to read these truth tables in your chapter. Then it talks about precedents and operators in your chapter as well. Then it also talks about you can also compare strings, just like you can compare numbers and variables. You can also compare strings, and it gives you various examples. You can compare these values by themselves or values in the variables. You can check which string variable is larger or smaller. You can also use compound statements. Compound statements are when you have multiple statements in the curly braces. These are compound statements. I actually recommend for my class, even if you have one statement underneath if or a loop, you still use the curly braces. It is highly recommended for my class. Here's an example. I used a similar example in the past. If age is greater than 18, do these things. Else, if the condition is false, do these things. Okay, that's an example of a compound statement. You can also do nesting. Nesting is highly recommended. So in this case, you have the first condition. If the first condition is false, goes to the second condition. If the second condition is false, goes to the third condition, and on and on. If the first condition is true, then it skips the second, third, fourth, and fifth, and it goes directly outside of the if structure. So if the first condition is true, it executes the statement, and then it exits the entire structure of the if condition. Okay. All right. We're almost done with if and else. And it shows you an example here. You can look at the example on the slide number 40. All right. This is a mistake in this statement. Remember, in Java, C++, C#, there's a difference between equal sign, single equal versus two equals. Equal equals means equality. Single equals means assignment. So this is a logical error here. Here, what I was trying to test, if x equals 5, x is equal to value 5. However, that's not what we are testing here. Here what we are doing is we are assigning a value of 5 to x, which is a logical error. So make sure when you are running these programs, you're careful what you're trying to achieve here. All right. The chapter also talks about pseudocode. Pseudocode is English-like code written in plain English, so to understand or break down the complex steps into more manageable, easier to understand steps. So you can read the pseudocode definition in your book. All right. Lastly, we have a switch case. So there are three types of control structures under selection. The third one is called switch case. The switch case is useful when you have specific kind of continuity in your data. For example, you're checking room numbers, you're checking GPA, you are checking certain values, characters A, B, C, D in a certain sequence. The switch case is useful for that one. However, switch case doesn't work very well with double data type and string data type. So if your data type is characters and integers, switch case works very well. So let's take a look at the switch case. So you use the word switch, and in the expression, you put the data, a variable type of which you are trying to evaluate. And we'll see an example in a minute. And then you have multiple cases, case 1, case 2, case 3, and the default case. And the switch case ends right here. So this is the body of the switch, starts right there, and ends right here. Let's take a look at a real example of switch case. So this is a good example of switch case. This is on slide number 51. So let's say you're trying to evaluate grades A, B, C, D, and F. So those are single characters. Those are not strings. Those are characters. So you will say switch, and as your variable, grade, that will be incoming value. Either the value comes from a user, value comes from a file, value comes from a database. Whatever the value comes in, it's going to evaluate the incoming value with the first case. And that's what we are saying. If case A matches the grade, if case A matches the grade, then this statement will be true, and it will display this result. The grade point is 4.0. Then it needs a break statement to exit from switch case structure, to exit out from the switch case structure. If the first condition is not true, let's say the incoming grade is B, then the second case will be evaluated and verified. So it's going to run the second statement here, and then it breaks from the switch case. Otherwise, it will go to the case number C, case number D, case F. If none of these grades match the criteria, then it goes to the default, and it says the grade is invalid. Again, so switch case is useful when you have simpler values, such as simple characters, simple numbers, whole numbers. But if you have more complex data type, such as strings, doubles, then it is recommended you use if or if and else, right? We are done with the chapter, and let's talk about this project number 4. Now, the project number 4. In project number 4, this might require a little bit more time from your side. We will try to create a quadratic equation and solve the quadratic equation. Now, if you remember, the quadratic equation has can be divided into two parts, which is minus b plus minus b squared minus 4ac 2a, or you can actually say x1 equals to minus b plus b squared minus 4ac divided by 2a, and the second equation could be x2 equals to minus b minus. So that's the difference between the plus and minus here, between equation 1 and equation 2. B squared minus 4ac divided by 2a. Now, here's the deal in quadratic equation. Sometimes the value inside the square root could be positive, could be 0, or negative. So there could be three types of solutions. The value inside, which we call a discriminant, inside here could be positive, could be 0, or could be negative. So when you have a value which is positive, you'll get two real solutions. The value in the discriminant, which is inside the square root, if the value is positive, you will get two real solutions. If the value of the discriminant is 0, then you will get one real solution. If the value of the discriminant is negative, then you will get two imaginary solutions. Now, imaginary solution is, which means, what if we get a value which looks like this, -1 under root. We do not know the solution for this one. Mathematically, we don't have a solution available for this kind of problem. So we actually use I or iota to represent an imaginary value like this one. And that's exactly what we are going to do. What if the value inside the discriminant is a negative value? How do we represent successfully without crashing the program? Because if you try to take a square root of negative value, it's going to crash your program. So you have to be very careful by using if conditions. You have to check if the discriminant is greater than 0, or discriminant is equal to 0, or discriminant is less than 0. So it's very critical that you calculate the value of the discriminant first in order to determine if the value of the discriminant is equal to 0, greater than 0, or less than 0. If the value of the discriminant is less than 0, somehow, and you have to take some time to figure it out, somehow you need to calculate the value inside the square root or discriminant and convert into positive value. When you're converting into positive value to take the square root of that particular value, you still need to remember that you actually had converted into positive value. So you represent by showing I or -1 with that one. So let's take a look here. So for example, if I take the first data set, if you look at the second page of the handout, if I take the first data set, if I plug in these values for A, B, and C in my equation, I'm going to end up with two real solutions, or value inside the square root or discriminant will be positive. So for the first equation, the value will be 3, and this is shown in scientific notation. And if you have not read the previous chapter, you'll say, how do I show values in scientific notation? All you have to do is simply somewhere on the top of your program, you have to say cout scientific. Cout scientific. So this is one of the manipulator we have from chapter 3. So when you say cout scientific, your result will be shown in the scientific notation as shown over here. Okay? So this is the first equation. This is the second equation. Remember, minus b plus b squared minus 4ac divided by 2a. So that's your first equation. Minus b minus b squared minus 4ac divided by 2a. That will be a second equation. And if you use those data sets, this is the value of A, this is the value of B, value of C. If you plug in these values in the equation, you will determine the discriminant is actually positive. That's how you get those answers. However, if you look at the next data set, this is the data set which is going to give a lot of you a lot of trouble. So I recommend highly that you go step by step. First, try to figure out what the discriminant is. So for example, if in this data set, if the value is A is equal to 2, B is -5, and C is 4, you will end up with negative value in the discriminant. So convert that into positive value first. And you say, how do I convert discriminant into positive value? Well, you have multiple ways. We have a function available called ABS, absolute. You can use that function. Or you can actually use a more primitive method. You can simply do this. Let's say discriminant equals to discriminant multiplied by -1. This is a more primitive way to convert your discriminant into positive value. This will only happen when you already have tested if the discriminant is less than 0. If it's less than 0, then you'll convert into positive value. But if you do that, then you have to display the I next to it. As you can see, I is next to it, showing or demonstrating that this was an imaginary solution. So this set will give you a lot of trouble. So I recommend highly that you spend time and understand how the problem is going to work out. If the value of the discriminant is equals to 0, and if you put this data set, it's going to become equal to 0, then you only show one solution. For both equations, it will be exactly the same, so you just need to show one answer, not two answers in this case. However, there's another situation. What if the value of the denominator, value which is in your equation, the value in the lower end is 0, such as value of a? If the value of a equals to 0, we don't have a solution for that problem as well. So because we do not know what is 1 over 0 means. So in that case, if the value of a equals to 0, then you simply say no solutions will be calculated because we do not have solution for that one. All right, guys, I think this will make a lot of sense if you go through the chapter and spend some time figuring out the problem. Thank you.